Miss Miklos here, and in today's lecture we are going to be talking about the properties of logarithms. And there's really four major properties that we're going to be talking about today. So if you haven't done so already, go ahead and take out the note handout that is up on my Loom. That'll help you out. And the first property we're going to talk about today is product property. And we know when we hear the word product, we think of multiplication. So we have log base b of u plus log base b of v. The important part here is that I'm adding together two logarithms that have the same base. Okay, so this property will only hold true if this base is the same. If that is true, we can go ahead and we can condense this into a single logarithm. That would be log base b of u times v. So what we're seeing here is that addition and multiplication are linked together. This same property holds true for ln of u plus ln of v. Since we have the same base, I can do ln of u times v. So notice when I'm using the product property, there's two ways that we can go about doing it. One is the way we're looking at it, where I'm going from addition into multiplication, and we call that condensing something into a single logarithm. The other way is going to be the opposite, where I'm going to take this single logarithm and expand it. Okay, so those are really the two things that we're going to see. Next, we have our quotient property, and we know quotient means division. So this time, once again, I have the same base. Instead of addition, we have subtraction. And so what we're going to go ahead and do, this is going to become log base b of u divided by v, or ln of u divided by v. So what we're seeing here is that when we have subtraction and we want to condense it, it goes into division. On the other hand, if we were expanding and we had division, we know we could write it as subtraction of different logarithms that have the same base. The third property we're talking about we call our power property, and that's because we have this power, this exponent. And what this is telling us to do is that if I have an exponent, and I'm actually going to draw this all out for us here. If I have an exponent here, I can move this out in front to become a coefficient. So log base b of u to the n power becomes n times log base b of u. Same thing occurs when we have ln, it becomes n ln of u. So when we have a power or an exponent, it becomes our coefficient. Okay, when we are trying to go ahead and work backwards, when we have a coefficient, I can put it out in front and it becomes our exponent. So we definitely need to have these three properties memorized. We're going to do some easier problems with those, and then we're going to get into some tough ones, okay? So here are our easy examples. It's asking me to expand. So that means I want to write this as more than one logarithm. So when we are expanding, there's kind of a little formula that we normally follow in order to do everything correctly. The first thing that I want to look for is if we have any multiplication or division to turn into addition and subtraction. So if I look at this logarithm, I notice it is 2 times x to the 6th. So I'm going to go ahead and write log base 5 of 2. Since it is multiplication, I know that becomes addition of log base 5 of x to the 6th power. So we've taken care of all the addition and subtraction by looking for multiplication and division in this original problem. Now I need to look for any exponents, and I know that's going to become a coefficient. And we do have one exponent here. So I'm going to go ahead and write log base 5 of 2 plus my exponent goes out in front and becomes my coefficient, 6 times log base 5 of x. So this would be our final answer. We are just expanding the expression. We're not solving for anything. The reason why I need to change multiplication and division first is because only the x is being taken to the 6th power. So it would be inaccurate to put a 6 in front of both of these because that would indicate that 2 is being taken to the 6th power, which is not true. So number 2, we're going to follow the same type of problem, or the same route of thinking here, the same line of thinking. And I notice that I have some multiplication and I have division. And the first thing that I'm going to do is put parentheses in my numerator and denominator. And even though this is not always important, sometimes it becomes extremely important, and we'll kind of see why. So I'm going to go ahead and write log base 2 of 7 plus log base 2 of x cubed minus log base 2 of y. So what I did there, 7 times x cubed, that was all in the numerator, so I kept that in parentheses. Multiplication became addition. Then divided by became subtraction, log base 2 of y. Now the reason why these parentheses could become very important is because if I had more than one thing in the denominator, we would need to distribute this negative to multiple things. However, in this case, there's just one term there, so we're okay. I know I'm not done yet because I need to see, do we have any exponents that can be turned into coefficients? And we do, so my answer is going to be log base 2 of 7 plus 3 log base 2 of x minus log base 2 of y. So hopefully at this point we're feeling pretty good on this because I will warn you, this is typically what we're, not these problems, but what we're going to get into at the end of the lecture for a lot of people is the toughest thing we do in this particular chapter, because we tend to use these properties in our next lesson when we learn how to solve logarithmic functions. Okay, number 3. First thing we're looking for, do we have division or multiplication? And I do, and I'm going to put those parentheses around there again. So I'm going to write log base 7 of y minus log base 7 of 3 plus log base 7 of x squared. And I do want to make a note that it's really important that we're writing this base. If I forget to write that base, I will get an incorrect answer. And you guys may have guessed, but that is one of the most common mistakes I see. On this problem, these parentheses become really important because I have to distribute, so I get minus log base 7 of 3. And I'm going to do two things at once. I notice that I have this exponent, so I'm going to bring that out in front and distribute the negative, so I get minus 2 log base 7 of x. Number 4 here, this is the only time that it would actually be okay to not write our base, because I know log base 10 is our common logarithm that we can just denote as log. Now something kind of weird is happening on this one, and what I'm noticing is this whole square root of b. So the first thing that I'm actually going to do here is I'm going to rewrite the square root of b as b to a power, and we learned last chapter that this would be like b to the 1/2 power. So at this point, I am going to go ahead and split up my multiplication by doing log base 10 of a squared plus log base 10 of b to the 1/2 power. Then I'm going to go ahead and bring my coefficients out in front by moving those exponents into coefficients. So I get 2 times log base 10 of a plus 1/2 times log base 10 of b. So this is kind of the simple, generic example of how we expand expressions. Our next section is asking us to condense. And I want us to remember that condensing really means I'm just simply writing it as a single logarithm. So when I'm writing things as a single logarithm, this is really what I'm going to look for. First, we are going to go ahead and look for coefficients and change them into exponents. Secondly, I'm going to find any addition and subtraction and change it into multiplication and division. So if we look at number 5 here, the first thing that stands out to me is that we do have one coefficient. So I'm going to go ahead and write log of 6, and I'm going to pause here. And note that this is our common logarithm since we don't have a base written. Okay, unpause. So now 2 log of 2, I'm going to make this log of 2 squared minus log of 3. So that was step 1. Now I need to look and see, do we have any addition or subtraction that we can make into multiplication or division? And we definitely do. So I'm going to have log of, it is 6 plus 2 squared. So I'm going to write that as 6 times 4, because 2 squared is 4, divided by 3. So just kind of to show where all this is coming from. Plus turned into multiplication here, minus turned into the division. Notice that I wrote this as a single logarithm. Now we can actually do more here where I can make this log of 8. And if we wanted to, we could actually figure out what log of 8 is, because that's something that we know we can put straight into our calculator. So just kind of to recap, look for coefficients, those turn into exponents, addition and subtraction turn into multiplication and division. So let's go ahead and do number 6 here. So first thing I'm looking for once again are coefficients, and I noticed that we have some. And I should actually say, before we even do that, in order to do this and condense, I need to make sure we have the same base, which we have had. But if for some reason this said log base 4, we could not use any of these properties. So this is going to become log base 3 of 7 squared minus log base 3 of x to the 5th. Now that I'm done with my coefficients, I need to look for addition and subtraction. I have subtraction here, and I know that turns into division. So I have log base 3 of 49 over x to the 5th. 49 came from 7 squared. Notice that my final answer is a single logarithm. It's not log base 3 of 40 divided by log base 3 of x to the 5th. I only have one logarithm written out. Number 7 looks like a doozy because I have this weird divided by, but luckily I know you guys are all super smart. And we know that dividing by 2 is the same thing as multiplying by 1/2. So I'm going to write this as minus 1/2 log base 6 of m. Okay, so now I'm actually going to demo this in 2 different ways, so hang with me here. Okay, the first way, I know I need to move these coefficients into exponents. So the first way I'm going to do it, I'm just going to keep this minus here and just put the 1/2 as our exponent. So that would become log base 6 of m cubed minus log base 6 of n to the 1/2 power. I don't know why that looks like an m. That's an n. There we go. Okay, so now I have subtraction, so I can write this as log base 6 of m cubed over into the 1/2, which is really the square root of n. Now, if we're being really technical, we shouldn't have that in the denominator, but since we're just dealing with logarithms, I'm okay with it. We could write it as into, or if you wrote it as into the 1/2, I would not give you full credit. We do need to simplify that, which we know into the 1/2 is the square root of n. Okay, so to me, this is the way I would normally go about doing it. I think this is the easier way, but let me show you a second way we could do this problem. This time what I'm going to do is I'm still going to make this log base 6 of m cubed, but I'm going to go ahead and treat this like a negative 1/2. So I'm going to write plus log base 6 of n to the negative 1/2 power. So when I condense this, it becomes log base 6 of m cubed into the negative 1/2, We know we cannot have negative exponents, so it becomes log base 6 of m cubed over into the 1/2 or over the square root of n. So I get the same answer either way, but I just want to point out that subtraction, if I go ahead and combine that with my coefficient, then I'm dealing with negative exponents that we'll just have to move around and change to make them positive. We'll get back to those properties in a little bit, but we're going to go ahead and talk about what we call the change of base formula. And this is a lovely formula. It's going to make our life so much easier. In previous lectures, I've talked about the fact that the only bases we could put into our calculator were a base of 10, which was our common logarithm, and a base of e, which was our natural logarithm. And now everything's going to change because we can put everything in our calculator using the change of base formula. So there's two ways we could do it. If I have log base a of b, it is going to become log of b divided by log of a. What I want to point out here is that whatever's in the subscript stays in our denominator. The other way we could do this, instead of using log, we could do ln of b divided by ln of a. I just need to be consistent if I'm using my common log or my natural log, and this ratio will be exactly the same as this ratio. So what this enables us to do now is we can put any base, convert it using change of base, and put it into our calculator. Very important that we use these parentheses, especially in the numerator, otherwise we may get an inaccurate answer. Okay, so for number 8, I'm going to go ahead and do it two ways just to prove to us that it does not matter how we do it. So I have log base 3 of 7. So the first way that I could do this is log of 7 divided by log of 3. And once again, if I do not close this parenthesis, you will not get the correct answer. So I'm going to go ahead and put this into my calculator. And I end up getting 1.771 as my answer. If you're not getting that, recheck it, put it in your calculator again. Okay, the second way I could have done this was ln of 7 divided by ln of 3. And amazingly, when I put that in my calculator, I get 1.771. So I do not care which of these two methods you use. We get the same answer. We get the same ratio. Okay? It does not get any more difficult than this. Key thing to remember, what's on the bottom stays on the bottom. Subscript stays on the bottom. So let's do one final one. This time I'm just going to use log. So I'm going to do log of 15 divided by log of 6. And I get 1.511. So even though this particular concept is not on your walkthrough, it is something that comes up a ton in our next lecture. So you will definitely want to make sure that you understand this concept by doing some of the suggested practice problems. So now we're getting into the tough stuff here. So I'm letting you guys know there's stuff like this on our test, and if you guys spend time on the fancy log worksheet and on this, you will be in good shape for that. So it says use the properties of logarithms to rewrite the expression in terms of log of 3 and log of 4. Okay, so basically what that means is I want to expand into terms of log of 3 and log of 4. Then it's giving me these values that log of 3 and log of 4 are equal to in order to approximate the expression. So we're starting off with actually kind of an easy one here. 10 equals log of 3/4. So what I'm thinking here is if I'm expanding it, this could be like log of 3 minus log of 4. Because I know that division means subtraction. So now I have it in terms of log of 3 and log of 4. So I'm going to go ahead and substitute in those values. So it says log of 3 is 0.477. and log of 4 is 0.602. So I'm going to go ahead and put that into my calculator, and I get negative 0.125 as my answer. So in these problems, we should be getting some sort of decimal value as our final answer because they want us to substitute in for log of 3 and log of 4. So step 1 is to expand log of 3, log of 4. Then step 2 is to substitute in. Number 11 is a little bit tougher, so I need to think to myself, is there any way that I can rewrite 12 in terms of 3 and 4? And the reason why I'm thinking 3 and 4 is because those are the numbers that it gave us in the directions. So I know that 12 is equal to 3 times 4. And at this point, I can go ahead and split this up. Since they were multiplied, I can go ahead and use addition. Now that I have those split up as log of 3 and log of 4, I'm substituting in for log of 3 and log of 4, and I need to add these two decimal values together. And when I do that, I end up getting 1.079 as my answer. So kind of looking through this again, first thing we had to do, we had to manipulate 12 to be in terms of 3 and 4 because those were the two numbers given to us in the directions. Then once I had them written in terms of 3 and 4, I had to use our properties that we just learned to split them up and expand. So since it was multiplication, we changed it into addition. Once I have log of 3 and log of 4 by itself, I can substitute in and then find out what our final answer is going to be. Number 12 is the toughest one here. So looking at this, I think our numerator is good because it's 4. Our denominator of 27, I need to think, can I make that 3, like in terms of 3, can I make it in terms of 4? And I know 27 is 3 cubed. If you wanted to, you also could have written 3 times 3 times 3. If for some reason I cannot simplify it like this, I would look at this fraction and see if I could simplify that fraction by reducing or something like that. Now I'm going to go ahead and make this log of 4 minus log of 3 cubed, because that is following the way that we learned how to expand, where I changed division into subtraction. The most common mistake I see here is that students want to try and substitute in for log of 3 right now. The problem is, this is not log of 3, it's log of 3 cubed. So I need to go ahead and move that exponent out in front to become a coefficient. So then when I substitute in, I have 0.477 minus 3 times 0.602, because that's what log of 3 is equal to, which gives me negative 1.329. Okay, moving on to the next section. This is actually my favorite. It says evaluate each logarithm given log of A equals 3, log of B equals 5, and log of C equals 6. So what this is basically telling us to do is to split it up in terms of log of A, log of B, and log of C. So once again, I'm expanding here. This time though, instead of log of 3 and log of 4, I want it to be in terms of A, B, and C. So I'm going to start this problem by splitting up my multiplication with addition. So log of A cubed, log of B squared, plus log of C. Now once again, I do not have log of A or log of B by itself yet, so I need to move those exponents to become coefficients. So I have 3 log of A plus 2 log of B plus log of C. So now I can go ahead and substitute in the numbers that were given to us. So log of A was 3, log of B was 5, and log of C was 6. Now this becomes an algebraic expression. So I get 9 plus 10 plus 6, which gives me 25. So 25 would be our final answer. So once again, I'm going to go ahead and start by expanding to get log of A, log of B, and log of C by themselves. Then I'm substituting in those values, 3, 5, and 6, because that was given to us in the directions. And then I'm simplifying that algebraic expression. 14, we notice that we have a square root of this entire thing. So the first thing that I'm going to do is I'm going to think of this as a to the fourth b over c to the 1/2 power, which would become a squared b to the 1/2 over c to the 1/2. And once again, that's because since this is a monomial inside my parentheses, I need to take each of these variables to the 1/2 power. I know when I'm taking an exponent to a power, we multiply. So now I'm going to have to expand. So I'm going to do log of a squared plus log of b to the 1/2 power minus log of c to the 1/2 power. So I split up this multiplication with addition. I split up the division with subtraction. Now I'm not done because I don't have log A, log of B, log of C by themselves because I have all these exponents. So I need to make those into coefficients. So I'm moving those coefficients out in front of all three of them. Now I can go ahead and substitute in 3, 5, and 6. So if I'm going through this problem, I get 6 plus 5 halves minus 3. So I could think of that as 3 plus 5 halves, which would be like 6 over 2 plus 5 over 2, or 11 over 2. So we're following the same idea here. The only thing that made this one a little tougher was dealing with that square root, which we knew was really like a 1/2 power. Final problem of the lecture. First thing I'm doing is I am splitting up these logarithms. Since they're all multiplied together, I can go ahead and use addition. Then I know that I need to go ahead and move all my coefficients out in front. Or I should say move my exponents into coefficients. Now I have log of A by itself, and I know that is 3, log of B by itself, which is 5, and log of C by itself, which is 6. So I get 2 plus 5 plus 3 over 2. I know 2 plus 5 is 7, which I could think of as 14 halves, plus 3 halves, which is 17 halves. So these problems are really good because not only are they testing if we understand the properties, but it's also testing if we have a sound mathematical background in just the way we think. It's also testing, whoa, I didn't mean to do that. It's also testing if we can simplify algebraic expressions. 100% expect stuff like this on our test. And your walkthroughs are problems like this, so you may need to do a few practice ones before you do your actual walkthrough.